this is the Chapter 6 review. So 6.1 has to do with ratios and rates. A ratio is a comparison of two numbers. It can be written in three different ways. It can be written as a fraction, 2 over 3. It can be written using a colon, 2 to 3. And it can be written as just words, 2 to 3. It is always comparing two different things, like 2 females to 3 males, or 2 cats to 3 dogs. A rate is a ratio of two measures having different kinds of units. So you might have something that you're buying for $3 and you get 4 pounds of that item for $3. A unit rate is that rate that is simplified so that the denominator is 1. So if I took this up here and divided both of those by 4 so that I had 1 on the bottom, I would get 0.75. So 1 pound of this item cost 75 cents, and that would be considered a unit rate. In section 6.2, you were using proportions and you were doing a couple different things with them. First, you were trying to see whether they were equal. So to see if they're equal, you're going to cross product here, and you're going to understand that 2 times 20 is 40, and 3 times 12 is 36. So this would not be equal. That would not be what we call a proportion. This one, we have 8 times 20, which is 160, and then you have 5 times 32, which is also 160. So then I would put an equal sign between those two because I know that they are equal or proportional. Sometimes on proportion problems you have an unknown. So you have an n or an x. And so you're going to do the same thing to solve it. You're going to cross product. So on one side you have 18n, and on the other side you have 12 times 6, which is 72. Now to finish this problem, obviously my 18 is multiplied by the n, so I would have to divide to get rid of it. So 72 divided by 18 is 4. So n is equal to 4. So 4 would be what would make this proportion true. Let's do another one. We have 7 times c and 5 times 28. So I have a 7c on one side, and I have 140 on the other side. So I'm going to divide by 7, and I get c is equal to 20. All right, section 6.3 has to do with scale drawings and models. It's often used in maps or in models. A scale gives you the relationship between two different items. For example, the scale might compare the measurement of a model versus a similar measurement in life. For example, 1 inch is equal to 4 feet. A scale factor has the same units if possible. So like above, if I wanted to turn this scale into a scale factor, I know that there's 12 inches in a foot, so all of a sudden this 1 inch equals 4 feet. As a scale, the scale factor is 1 inch equals 48 inches. Example, this is an example from section 6.3. On an architectural drawing for an office building, the scale is 0.25 inches is equal to 5 feet. Find the actual length of the lobby if the measure is 1.8 inches on the model. So I have two categories. I have model and I have actual, and I'm going to write those down so that I know what measurements go on the top and what measurements go on the bottom. So 0.25 inches on the model is comparable to 5 feet in actual. Well, the other number that I have is 1.8 inches on the model, so that's going to go on the top, and my unknown is on the bottom because that's the measurement in actual that compares to the 1.8 inches. So to solve it, I'm going to cross product. So I have 0.25 is equal to 0.25x, I'm sorry, is equal to 9. And then to solve it, I'm going to divide by 0.25. And I'm going to get x is equal to 36. So 1.8 inches on the model is comparable to 36 feet on the actual building. All right, section 6.4 has to do with fractions, decimals, and percents. You have to be able to go back and forth between them. So if they ask me to write a percent as a fraction, I take the percent, I place it over 100, and then I reduce it to lowest term. So on this particular one, I divided the top and the bottom by 2 to get 17 over 50. This is 0.24%. I'm putting the 0.24 over 100. I'm not allowed to have a decimal in a fraction, so I have to multiply the top and the bottom by 100 to move the decimal 2 places to the right. Then I can reduce this by dividing the top and the bottom. I divide both of those by 8, and I got 3 over 1,250. You also have to be able to write a fraction as a percent, and there's 2 methods. The first method, I'm going to use proportions. So I've got 3/10, and I'm going to set it up as x over 100, because whatever the x is going to be what my percent is. So I'm going to multiply, so cross product there. I get 10x is equal to 300, and when I divide by 10, I'm going to get x is equal to 30. So this is 30%. So 3 over 10 is 30%. The other method is I make it into a decimal first. So I go 10 into 3, the bottom into the top, put the decimal straight up, it goes 3 times. So now I have a decimal, but I need to move my decimal 2 places to the right to make it a percent. So I have to add a 0 there so I can move it. So you notice you get the same answer. It doesn't matter which way you decide you want to do it. Here's another one. I have 3 1/4. I know that the decimal value for 1/4 is 3.25. Okay, so I can take that and I can make it as a improper fraction. Okay, so I'll save the decimal for over here. Okay, so my decimal, I'll go ahead and move it here. And then all I would have to do is move it over 2 places, so I have a 325%. Okay, now back over here, I'm going to take this and make it into an improper fraction. So I have 13 over 4 is equal to x over 100. So I'm going to cross product. So I have 4x is equal to 1,300. I'm going to divide both sides by 4. And I'm going to get x is equal to, it's going to give me the exact same thing. Okay, so it doesn't matter which method you choose to do. All right, we have to be able to write a percent as a decimal. I'm simply going to move it 2 places to the left. So this becomes decimal 327 because I moved it 2 places. This one, the understood decimal is behind it, so it's going to become decimal 0.5. I've got to add a 0 in front so I can move it 2 places. To write a decimal as a percent, we already just did that. I'm going to move it 2 places to the right, so that's going to give me 30%. Understood decimal here, 2 places to the right, is going to give me 400%. Section 6.5 and 6.7, you were working with percents and problems. We put the 2 sections together because we did it the same way in both sections. I'm going to work through some examples. Remember, the key word is the word of, and the number on the behind of goes on the bottom. This part gets made into a percent. So on this particular problem, it says what percent of 24 is 21. It's the percent part that I don't know. So that's going to be x over 100. I'm going to cross product, and obviously the 24 is on the bottom, the 21 is over it. So I have 24x is equal to 2100. So in order to solve this, I'm going to divide by the 24. So I have x on the left-hand side, and I have 87.5 on the right-hand side. So that's what my x value is. But it asks for a percent. So if it asks for a percent, you know you need to put the percent sign on your answer. What is 30% of 54? I know the percent, so I'm going to write it as a fraction. The number after of goes on the bottom, and my unknown is on top. So I'm going to cross product. I'll come over here so I have room. 100x is equal to 54 times 30, which is 1,620. I'm going to divide both sides by 100, which is going to move my decimal 2 places to the left. So I'm going to get 16.20. So now that is not a percent, but what I have found out is 16.20 is 30% of 54. 13 is 50% of what number? So again, I have my percent. I have 50 over 100. What's after of is the unknown, so that goes on the bottom, and the 13 goes on the top. So I have 50 times x is equal to 1,300. So then I'm going to divide both sides by 50, and I'm going to get x is equal to 26. So 13 is 50% of 26. 7 is what percent of 350? I put the 350 on the bottom. My percent is what I don't know, so I have x over 100, so my 7 is going to go on the top there. So I'm going to go cross product again. So I have 350x is equal to 700, and I'm going to divide both sides by 350, and I'm going to get x is equal to 2. So this is talking a percent, so I have to write it as 2%. All right, last one like this. Find 75% of 312. I know my percent, so I write it 75 over 100. Of 312, so 312 goes on the bottom, x goes on the top. Cross product. So I have 100x is equal to 312 times 75 is going to give me 23,400. I'm going to divide both sides by 100, and I'm going to get x is equal to 234 because it's going to move my decimal 2 places to the left. All right, section 6.8 is a percent of change. You always are going to put it in the correct formula, and the formula is difference or change divided by original. So difference or change over original. And then you're going to take this, whatever you get here, you're going to change it into a percent by either method. You could set it up with equals x over 100, or you could make it a decimal and move your decimal 2 places to the right. Here's an example from that particular section. In 1965, when John entered college, the tuition per year was $7,500. In 2000, his daughter went to the same school. The tuition was $25,500. Find the percent of change. So the original is $7,500. The new is $25,500. So to get the change, I'm going to take $25,500 and subtract $7,500 from it, and I'm going to get a change of $180,000 that I'm going to place over the original, and I'm going to get a decimal value for that. And the way that I'm going to do that is I'm going to divide the top by the bottom. So 180,000 divided by 7,500 is going to give me 24. Now, that's actually a decimal value, which I have to, there's an understood decimal there. I have to make it into a percent by moving it 2 places to the right. So there is a percent of increase of 2,400. Okay, because it goes up, it's a percent of increase. If it were to go down, it would be a percent of decrease. Section 6.9 has to do with probability. Probability can be written as a fraction between 0 and 1 or as a percent. If something will for sure happen, the probability is 1. So in other words, if it's raining and I say, what's the probability of rain? The answer would be 1. If something for sure will not happen, the probability is 0. So the probability of a purple dotted elephant walking through the math door is 0. Probability is equal to success divided by total. Okay, here's an example. Okay, what is the probability of selecting an even numbered card from a normal set of cards? So I know that the total number of cards is 52, but in every single suit I have the numbers 2, 4, 6, 8, and 10. So that's 1, 2, 3, 4, 5 in every suit. So there are 20 even numbers in a set of cards, because I have these numbers in hearts, these numbers in diamonds, these numbers in spades, and these numbers in clubs. So my probability is 20 over 52. But then I have to divide this, and I can to reduce it. So I can divide it by 4, so that's going to give me a 5 on the top, and it's going to give me a 13 on the bottom. So the probability is 5 over 13. If they wanted it as a percent, I would take the 5, divide it by 13, and find out that that's equal to 0.385 rounded. So I would move the decimal 2 places to the right, and it would give me 38.5%. Okay, many times they don't ask for it as a percent. They're just okay with it being a fraction. So here's another problem. What is the probability of putting all the letters of Mississippi in a container and randomly pulling out an S? So first I got to count the number of letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the total number is 11. That goes on the bottom. Then on the top, how many S's do I have? 1, 2, 3, 4 S's. So 4 of those letters would be considered success if I pulled them out. So that is the probability of 4/11ths. Your homework is on page 316 through 320, 17 through 39 odd, and 53 through 67 odd. We skipped the section that has to do with mental percentages.